Hello student, good morning. I am Dr. Ajay Kumar Sinha, Professor of Chemistry. Today I am going to discuss refining. Last class I have discussed electrochemical properties of metallurgy. Under that I have discussed aluminum, extraction of aluminum, extraction of copper. Now I am also I discussed last class oxidation, extractions based on oxidation. Generally extraction will be based on reduction, but last class I have discussed extraction based on oxidation. And also I have discussed last class three technique of refining of metals I have discussed. Under that, first I discussed distillation, second I have discussed liquefaction, third I discussed electrolysis. Now I am going to discuss next technique, zone refining. There are 6 techniques. Then 3 I discussed. Now fourth one is zone refining, fifth one is vapor phase refining, and sixth one is chromatographic technique. Then now today I am going to discuss, that is the fourth one, that is a zone refining technique of refining of metal. What is actually this zone refining? Now I am going to discuss. This method is based on the principle that the impurities are more soluble in the melt than in the solid state of the metal. A circular mobile heater is fixed at one end of rod of the impure metal. The molten zone moves along with the heater, which is moved forward. As the heater moves forward, the pure metal crystallizes out of the metal and the impurities pass on into the adjacent molten zone. Means forward pure crystal you will get, pure crystal of metal, and backward will be impurities that will go you can say adjacent molten zone, because metal crystallizes out at a high temperature in molten state. Then here pure metal will separate out from the impure. Okay, as the heater moves forward, the pure metal crystallizes out of the melt and the impurities pass on into the adjacent molten zone. The process is repeated several times and the heater is moved in the same direction. At one end, impurities get concentrated. This end is cut off. This method is very useful for producing semiconductors and other metals of very high purity, as for example germanium, silicon, boron, gallium and indium. These metals are purified, means in a very high purity, these metals are purified. That is germanium, silicon, boron, gallium and indium are purified by this method. Now next, actually this whole process is called zone refining process. ZONE, zone refining process. Now next technique I am going to discuss, that is the vapor phase refining. Vapor phase refining. In this method, the metal is converted into its volatile compound and collected elsewhere. It is then decomposed to give pure metal. So, the two requirements are required here. Actually, here two steps is done. First metal is converted into volatile compound. Volatile compound. Metal is converted into its volatile compound. That is the first thing. And second thing, this volatile compound is collected. Okay. After that, first important point, that it is converted into volatile compound and collected elsewhere. In second point, it is then decomposed. This volatile compound which is collected is decomposed to give pure metal. And here two requirements are used. Here two requirements are, I am telling you what are the two requirements for this method. I am telling you. First, the metal should form a volatile compound with an available reagent. And second, the volatile compound should be easily decomposed or should be decomposable so that the recovery is easy. Okay, these are the actually two requirements I have told you. Now example I am telling you. Two examples I will tell you. First example is a mound process for refining nickel. This is the first example. Mound process for refining nickel. And second, Van Arket method for refining zirconium or titanium. One by one I will tell you. Mound process, question is asked. For both process, for both examples, question is asked. Hence listen carefully. Mound process for refining nickel. In this process, nickel is heated in a stream of carbon monoxide, forming a volatile complex. Which complex it will form? Then complex name is nickel tetracarbonyl. Nickel tetracarbonyl means Ni plus 4CO. Temperature will be around 350 Kelvin, 330 to 350 Kelvin, and it forms NiCO whole 4, nickel tetracarbonyl. Now volatile compound is ready. Now second step, here what will happen? The nickel carbonyl is subjected to a higher temperature so that it is decomposed, giving the pure metal. Means nickel carbonyl NiCO4 now heated strongly, that is at 450 to 470 Kelvin. Around this it is heated. Then this compound will break. This compound will decompose and it will give nickel plus 4CO. Okay. Then in this way nickel is purified. Nickel now is a purified, means you got this thing pure form. Nickel you got in pure form. This is actually called vapor phase refining. Now another example of vapor phase refining, that is the Van Arket method, VAN, Van Arket method for refining zirconium, ZR, or titanium, TI, anyone. This method is very useful for removing all the oxygen and nitrogen present in the form of impurity in certain metals like ZR and TI, means zirconium and titanium. The crude metal is heated in an evacuated vessel with iodine. The metal iodide being more covalent volatilizes, means it becomes volatile, means ZR plus 2I2 both we are heating or is heated. This zirconium or titanium, anyone. The crude metal is heated in an evacuated vessel with iodine. The metal iodide being more covalent volatilizes, means ZR plus 2I2, it gives ZrI4, zirconium tetra iodide, or simply zirconium iodide. Now it is in the vapor form. This compound is in vapor form. Okay. Now next step, second step, the metal iodide is decomposed on a tungsten filament, means this metal iodide, means zirconium iodide, is kept on tungsten filament, and after that electrically heated to about 1800 Kelvin. The pure metal is thus deposited on the filament, means ZrI4, it is heated strongly on tungsten filament, and on heating it is heated electrically, then ZrI4 it decomposes and it gives ZR, pure ZR plus 2I2. Correct? This I have told you about the zone refining process. Now, this I have discussed. First one was the zone refining process. Now, this is called vapor phase refining. What I discussed now, that is the vapor phase refining. Two example I given you. Mond process for refining nickel, and second I told you Van Arket method for refining zirconium or titanium. Now next technique I am going to discuss, that is the last technique, chromatographic methods. Chromatographic methods. Here what is important things, listen carefully, this is very very important, and every time this question is asked. This method is based on the principle that different components of a mixture are differently adsorbed on the adsorbent. Actually, chromatography is used to separate the components. Suppose you have mixture of components, 3-4 mixed components are mixed, and they are in less quantity. 3-4, suppose 4 components are mixed, and you want to separate it, but all components are very less in quantity. Generally, organic compounds, it is used for organic compounds generally. For inorganic also it is used. Okay. Then here what is actually main you can say principle that these these mixture is dissolved in a suitable solvent to make a solution. Correct? This mixture is dissolved in a suitable solvent. And after that making the solution, now one this just like a burette you might have seen, tube, glass tube, long glass tube will be there. Then in that glass tube, this it is filled with some adsorbent. It is filled with some adsorbent. Solid substance will be filled in that glass tube. In that glass tube, solid adsorbent is filled. What is the purpose of that? This is solid. Then if you will pass, if that solution which in that mixture is dissolved in the solvent, now it becomes solution. Then if you will pass this solution through this solid which is kept inside the glass tube, then what will happen that suppose 4 components were mixed in the mixture, 4 components are there, then these four will flow through the adsorbent kept in the glass tube, but their speed will be different. Some will pass fast, okay, means some will dissolve more in the solution, and if you are passing it through the tube, then someone will pass fast and it will go inside, it will move with the solvent, and somewhere it will be adsorbed by the solid. After that, whose speed is less, that will be adsorbed, means a difference will be there between the first component and second component, because all 4 will be adsorbed at different places. Who is dissolved, this component who dissolved more in a solvent, that will move fast, it will go depth, and after that second one, then third one, then fourth one, means all will be adsorbed on the solid, means adsorbent at different places according to the solubility in solvent, and then at different position all 4 will be adsorbed. Then now later on, after drying this actually where they have adsorbed, actually this is removed. This component is kept out. It is actually made this thing solidify. It will dry, then later on it is separated from the solid. Means from the adsorbent it is removed. Then now all 4 were mixed, now it is separated. This is actually called actually this thing chromatographic method or chromatography. Main thing is that separation of components from the mixture. Then actually this is of various type. Sometimes liquids are there, liquid you want to separate, okay, liquid are mixed, 2-3 liquids are mixed, now you want to separate, then that also you have to dissolve in a suitable solvent, and again you have to pass. Same technique you have to apply. Then all 3-4 will be separated. Then according to the this what type of mixture is there, name has been given. Okay. Then various type of chromatography is there. Now I am going to discuss little details. Chromatography method is based on the principle that different components of a mixtures are differently adsorbed on adsorbent. The mixture is put in a liquid or gaseous medium which is moved through adsorbent. Okay. This means you have to make solution. Then solution how will you bring? Then you have to dissolve in liquid or sometimes in gaseous medium. And that mixture is after dissolving in a liquid or gaseous medium. The here medium means a solvent you are talking about. Solvent. Then this mixture after dissolving in a liquid or gaseous medium is moved through adsorbent. After that what will happen? Different components are adsorbed at different levels on column. Column means here same thing what I told you, just like a glass tube, in that adsorbent is filled. That actually is called column. Then different components are adsorbed at different levels on the column. Later the adsorbed component are removed. That is removal is called eluted. E-L-U-T-E-D. Eluted. Okay, elution. One term is there, elution. E-L-U-T-I-O-N. From that this term came eluted. E-L-U-T-E-D. Eluted. Then this is the removed. This is the removal actually. Adsorbed components are eluted means removed by using suitable solvents. That solvent is called eluent. E-L-U-A-N-T. Just to remove the adsorbed component, suitable solvent is used. That suitable solvent is called eluent. Depending upon the physical state of moving medium and the adsorbent material, and also on process of passage of the moving medium, the chromatographic method is given the name, different name according to this 3 points what I told you, depending upon the physical state of the moving medium first. Second, adsorbent medium, adsorbent material. Third, also on the process of passage of moving medium. Okay, means a solvent what we are telling. Then here according to the basis of these three, the chromatographic method is given the name. In one such method, the column of aluminum oxide is prepared in a glass tube. In a glass tube, you can make a column of aluminum oxide, means adsorbent what you are using, that is a solid aluminum oxide that you can fill in a glass tube. Okay, then that column is called column of aluminum oxide. One technique is like this. In one such method, the column of aluminum oxide is prepared in a glass tube, and the moving medium is a solution, you can tell mixture, moving medium containing a solution of components is in liquid form. This is an example of column chromatography. because colon is made, hence its name is given colon chromatography. This is very useful for purification of elements which are available in minute quantities, in very less quantities, and the impurities are not very different in chemical properties. Here I am telling you very important things, that mixtures, all 2, 3 component, 4 component, whatever be, their chemical properties should be very close, very close. There it will apply. There should not, too much difference should not be there in their properties. Similar, not 100% same, 70-80% same should be there. They should not differ too much. Then even you can say different impurity, what I am telling you, components, then in that components maybe 1, 2 important, other 2 may be impurities, but whatever be, that will be separated out. Okay. Then this I told about the colon chromatography. This is very useful for purification of elements which are available in minute quantities, and the impurities are not very different in chemical properties from the element to be purified. There are several chromatographic techniques such as paper chromatography, colon chromatography, gas chromatography, etc. Okay. Then this I have discussed about the this chromatography, that basic idea, and it is very long. This chromatography is one big chapter. Okay, but here in this class, in your level, this is sufficient. Okay, this is in BSc or MSc is discussed in very details. And now I have as a technique, chromatography is a technique for separation or for you can say purification. That's why I give an idea. Now I am going to discuss applications of aluminum, copper, zinc and iron. I have discussed these 4 metals in details. Then what are the application? Means uses of aluminum, copper, zinc and iron. Okay. Finally, you should know uses. You have from the ores, by following several method, you got the, by following the several process, from the ore you got the these things, a pure metal you got. Correct? You have done concentration. In concentration, many process you have studied. After that, you have done converted into oxide, metal oxide. And third step, you got from metal oxide, you got metal by reduction or by oxidation. After that, you have purified it. Correct? That is called refining. You have refined the, you can say, metal. Metal may have some impurities. Now you got pure metal. Then what you will do? What you will do of these metals? That is actually application or use. Then I will tell about these 4. That is the aluminum, copper, zinc and iron. First I will tell you about aluminum. Some uses you might be knowing. Okay. Hence other uses which you don't know, you should learn. Aluminum foils are used as wrappers for chocolates. You have seen already. Aluminum foils are used as wrappers for chocolates. The fine dust of the aluminum metal is used in paints and lacquers. Okay. Aluminum being highly reactive is also used in the extraction of chromium and manganese. Okay, aluminum being a highly reactive is also used in extraction of chromium and manganese from their oxides. Again, other use of application, wires of aluminum are used as electricity conductors, that you know. All alloy containing aluminum being light are very useful. Many products are there. Now I will discuss about copper. Usage of copper. One use you are knowing, that is the as electricity conductor, that you know. Other you understand. Copper is used for making wires used in electrical industry and for water and steam pipes. Water pipe and steam pipe, that is made up of copper. It is also used in several alloys that are rather tougher than the metal itself. Alloys are more tougher, more hard than the metal itself. As for example, brass. Actually, question is asked, what is the composition of brass? Then copper plus zinc. Copper plus zinc is called brass. Don't forget. Second, bronze. Then copper plus tin. Copper plus tin is called bronze. And coinage alloy, that is the copper plus nickel. Copper plus nickel is called coinage alloy. Question is asked. Again I am telling you, brass. Brass is copper plus Zn, means zinc. Bronze, copper plus tin. And coinage alloy, that is the copper plus nickel. Now I am going to tell about zinc. Zinc is used for galvanizing iron. It actually, you have to mix it with iron, zinc, that is called galvanizing iron. It is also used by this zinc is also used in large quantities in batteries. Zinc, you know, anode, it is used as anode in battery. Then zinc is used, first it is used in galvanizing iron. Second, it is used in large quantities, actually it is used in battery as a node. And next, as a constituent of many alloy. Zn is, zinc is constituent of many alloys. As for example, brass. Already I told you, brass. Here in brass, copper will be 60% and Zn will be 40%. Okay, brass, copper is 60% and Zn is 40%. And German silver, you might have heard the name German silver. Here copper will be around 30%, means between 25 to 30% copper, and Zn will be same 25 to 30%, means copper and Zn same percentage. And nickel will be also there in that. In German silver, three metal will be there, copper, Zn and nickel. Then copper will be, copper and Zn same percentage, means 25 to 30%. Copper, Zn also same 25 to 30% and nickel 40 to 50%. Next use I am telling you, Zn dust. Zn dust is used as a reducing agent in the manufacture of dye stuffs. Dye stuff color I am talking about. In paints also it is used. And next application, next use of cast iron. Cast iron, where actually this it's used, many used you might be knowing also, but which you are not knowing, just to try to learn. Cast iron, which is the most important form of iron, is used for casting stoves. Means a stove is formed, stoves you are using it for cooking, there it is used. Second, railway sleepers, you might have seen railway sleepers, railway track, there this iron is used. Railway sleepers. Gutter pipes, that gutter pipes, toys, etc. It is used in the manufacture of wrought iron, WROUGST, wrought iron, already I discussed, and steel. In wrought iron and steel, this cast iron is used, already I have discussed. Wrought iron is used in making anchors, wires, bolts, chains, and agriculture implements. Steel finds a number of uses. Alloys steel is obtained when other metals are added to it, as for example, nickel steel. Nickel steel is used for making cables, automobiles, and aeroplane. In that, nickel plus iron, you can tell, nickel steel. Correct? Steel, when in which nickel is there, that is called nickel steel, is used for making cables, automobiles, aeroplanes parts, etc. Also it is used in pendulum, measuring tapes, that you have seen. Chrome steel, where you are using chrome steel for cutting tools, it is very strong, hard. Chrome steel means chromium is present in steel. Chrome steel for cutting tools and crushing machines. And stainless steel is used, stainless steel, for cycles, automobiles, utensils, paints, etc. Okay, this I have discussed about the uses. Okay, and now I just before ending, finishing, I want to just brief it about the, you can say, general, you can tell. In general, this it is very useful, all four metals are very useful. And again, now I want to brief it that about the metal and their occurrence and common method. Okay, I want to brief it because all four are very, very important. Then first, aluminum, I want to brief about aluminum. Aluminum, its ores or occurrence, you can tell, that is the bauxite. Its formula is Al2O3 XH2O, and other occurrence means ores is cryolite. Okay, NaAlF6, Na3Alf6, Na3Alf6, that is called cryolite. And from this ore, by which method you will get this extraction, how will get the metal? Then common method of extraction I am telling you for aluminum, that is the electrolysis of Al2O3 dissolved in molten Na3Alf6. Okay, and for the extraction a good source of electricity is required. Now I am telling about other metal, okay, that is the iron. Iron, it's what is the ore? Then its main ore is hematite, Fe2O3. Second ore is magnetite, ferrosulfuric oxide, that is called Fe3O4. And what are the, you can say, this method of extraction? Then reduction of oxide with CO and coke in blast furnace. And here how much temperature is required? Then temperature approaching 2170 Kelvin is required. Maximum temperature means approaching 2170 Kelvin, 2170 Kelvin. Now third metal, that is the copper I am talking about. Its ore is copper pyrite, CuFeS2. And second ore is copper glance, that is the Cu2S. Third is magnetite, that is the CuCO3 CuOH whole 2, means cupric hydroxide, CuCO3 CuOH whole 2. And fourth one is cuprite, that is a Cu2O. Now, and what are the method of extraction? Then roasting of sulfide partially and after that reduction. And here it is a self, you can say, reduction. It is a self reduction in a specially designed converter. Self reduction takes place. It is a self reduction in a specially designed converter. Self reducer, you can say, self reduction. The reduction takes place easily. Sulfuric acid leaching is also used in hydrometallurgy from low grade ores. And last metal, that is the zinc. The zinc blend, or you can say, we are telling two name, zinc blend, that is a ZnS, also called sphalerite. Sphalerite, SPHALERITE, sphalerite. Formula is ZnS. And second, that is the calamine, ZnCO3. And third is zincsite, ZnO. Okay, you must remember all, you can say, ores. It is asked in examination. And for zinc, what is the, you can say, method of extraction? Then here roasting is done, followed by reduction with coke. The metal may be purified by fractional distillation. And now I have discussed in details this metallurgy. Completely I finished. Actually, in this general this metallurgy is also called, that is a general process, general, I can say, general principle of processes of isolation of elements. Correct? This is also called, what heading is long, that heading you know, general, you can say, principles of process and isolation of elements. In a shortcut, it is called metallurgy, metallurgical process, also metallurgical operations. And this chapter I have finished. Okay, next class I will start new chapter. Thank you.